hopefully, you know, this is like a 3-part bootcamp, and today we're doing the first part. The second one will be on Thursday this week, and the third part will be then on Tuesday next week. And this is very much around Apstra and how we see the ecosystem, you could say, around it. But before we get into Apstra today, we're going to look into more like basic things, which is good to know before you jump into Apstra. So today, as you can see here, part 1, we talk about different DC architectures, and also how we position our different platforms, QFX, PTX, as well as other platforms. So that will be the first session, and then the second session will be very much about telemetry. And why is that? Well, it's very important, even though Apstra has some telemetric capabilities. It's very important, we would say, to maybe add more visibility into how is your data center network actually doing. And that's why we have one session on telemetry. And then for the last 2 days, then, or for the other 2 sessions, then we will focus the whole next session on Thursday on Apstra, and continue doing some more Apstra on next week. And specifically, we have a live demo of NSXT integration, which I would recommend for you who would like to see that. And what we try to do with this session, and once again, if you have any questions, please put them in the Q&A, and me and my colleague Muttu will try to respond as quickly as possible. And what we're trying to do in these 3 sessions, or for the bootcamp, is to try to cover the whole process from discovery, proposal, demo to quote for a DC opportunity, you could say. Even though it's quite hard to cover all the steps, because, as you know, data center could be quite complex compared to other solutions. But that's the intention, and some of that will be covered today and moving forward in the other sessions. More importantly, when we look into what we're focusing on these, the bootcamp for these 3 sessions are mainly 3 things. As you can see, it's centered around Apstra itself. And the reason for that, as you know, that you could say is like the glue in the data center solution, where you do your design of your network, you deploy it, and after that also you operate it using assurance. But in order to do that, we also then we of course need some networking part, which is usually like a QFX, but it could also, as you might know, be an ACX or a PTX supported by Apstra. And of course, from a security point of view, there are lots of things we can do, and we have some good things we will discuss in the 3rd session of this bootcamp related to the SRX and some other things. And last but not least, telemetry. So the Paragon portfolio, some part of that will also be included in these sessions. And then you have some things which are grayed out, and those could potentially also be part of this, but we have decided for this specific bootcamp, we do not cover those. Based on interest, we might do a separate sessions moving forward. But for instance, for those of you who have been around for some time, Contrail is not covered today, as well as controllerless, which means, yeah, you can use Ansible more or less to build a fully spine leaf network using Ansible playbooks. And the public cloud, which is, you could argue it's like a VSRX, or could be the SSR or 128T, where we connect into the data center. Those 3 things are not covered, but might be in future releases. You never know. So today then, the last thing before we jump in, so the focus Apstra, not today, but rather on the platforms building the network, the QFXs, as well as the Paragon, the insights and assurance part. So this is the agenda. We appreciate this is a long session, it's 2 hours. So we are preparing to have a break in between somewhere, yeah, roughly like an hour from now. And until that break, we will then talk about DC fundamentals, architectures, and also how we could use the switching portfolio we have within different kinds of architectures. And then after the break, there will be very much a telemetry and Paragon. So why do we need telemetry? And more importantly, how can we derive some intelligence from our network by using telemetry and import that into, for instance, Paragon Insights or Paragon on Active Assurance. So with that short introduction, I will then hand over to Muthu. Muthu, are you ready to take us to the next step?
Sure, let me quickly share my screen.
Yes.
Are you guys able to see my screen? Is everything
Yes.
okay? Eric? Okay.
Yeah,
Awesome.
you can see it.
Okay, so welcome you all to the session on data center fabric architectures. So my name is Muthu Vaidalingam, and Eric is going to be in the background trying to answer your questions. If you have any questions, feel free to put them in the Q&A forum, and we will try to answer it either during or after the bootcamp. And the high-level agenda today, I just want to walk you through the different EVPN VXLAN architectures that you're currently seeing being deployed at customers, and we also want to give you some recommendations on what Juniper platforms are recommended for a certain architecture. So my idea is to introduce. Yes.
Sorry to interrupt. Could you please go full screen on your in presentation mode?
Yeah, sure.
Yes, and one thing I forgot to tell you is we're also going to have two questionnaires coming out. So one after this session and one other after the second session. So please, would be interesting to see if you could fill those out, and we just can look into results and maybe have see what you other partners look at and have a feeling about DC. So sorry about that interruption, Muthu, over to you.
No problem. So as I said, I'm going to introduce you to certain EVPN VXLAN architectures and also suggest certain Juniper platforms pertaining to a certain architecture. Especially the recommended architecture from Juniper is the edge routed bridging. And when we are talking about data centers, we also need to keep in mind the data center interconnects, because customers always deploy geographically redundant data centers, and they want to stretch their layer 2 and layer 3 domains to the data centers. And data center interconnect brings in certain unique challenges at the border leaf, right? That depends on what kind of solution we are finally deciding to go with, right? So, and I'm going to walk you through the different architectures in a consolidated view, and then identify what are the different roles that are available within the architecture, and also what Juniper platforms fits into that. So we are going to have a consolidated approach for this presentation. Especially, I'm going to talk about, as I said, the ERB with the OTT DCI and the seamless stitching stuff, and the collapse fabric for smaller DCs, and the IP clause fabric, that's also deployed by certain big enterprises and hyperscalers. All right. So I'm not going to share too much of slides. Instead, I'm going to switch to certain architecture diagrams. I hope, Eric, can you please confirm if you're able to see my architecture diagrams?
Yes, you can see it. Looks good.
Perfect. So what you see here, I'm going to flexibly zoom in and zoom out because this is a single view, but it has a lot of information, but I'm going to walk you through step by step so that you understand what's drawn here. So basically what you see here, there are two data centers. And to the left is data center 1, which comprises of some hosts. They are connected to some leaves. And then you have a spine, a couple of spines, and then there's a border leaf. So these are the networking gears present in data center 1. And the data center 2 is an exact replica of what you see on data center 1. It has the same leaves, spines, and the border leaf. And the two data centers are interconnected by an IP core, let's say, network, right? Where you want to extend your VXLAN tunnels between the data centers. So let's zoom in a little bit and try to understand what these individual components are, right? In a typical ERB design, the hosts are connected to the leaves via a VLAN, or sometimes they're also natively connected. But from an EVPN construct on a leaf, you typically have a broadcast domain or a bridge domain where you kind of map your physical interface to a VLAN, and then map it to an EVPN construct called a MAC VRF, which is basically an L2 VNI, which is also a VRF, but it's a layer 2 VRF, where it has, just like an L3 VRF, you have your route targets and RDs and RTs, route distinguishers, right? And then these connect to an IRB interface, which is your layer 3 interface, which is responsible for your ARP resolution and things like that. That's pretty where you configure your IP address, which is your default gateway, which then is part of an layer 3 VNI or a classical VRF in layer 3 terminology. So any vendor that you have on your DC, right, be it Juniper, Cisco, or Arista, when it comes to EVPN, you will have these 3 components, and bridge domain, and MAC-VRF, and which is layer 2 based, and VRF is an L3 VNI based, and IRB interface hanging on to it, right? So in the case of an ERB design, what happens is your layer 3 VNI is on the leaves, and the spine, there's pretty much nothing there. Your spine is not a VXLAN tunnel endpoint. What it does is just a plain IP routing, right? Whereas your VXLAN tunnel endpoints are basically your leaves and your border leaves. Your border leaf is exactly a similar setup like your leaf. It has your broadcast domain, your MAC-VRF and your layer 3 VRF, right? And a border leaf is a special leaf, right? Because that's your exit point out of your data center. And what I have shown you here is an ERB 3-stage design. A 3-stage in the sense you have a leaf, a lean spine, and a border leaf. And the data center interconnect is over the top data center interconnect. So what does it mean, right? So in the over the top data center design, you're extending your VXLAN tunnels from data center 1 to the second data center. So if I zoom out a little bit, you will see that there is an VXLAN tunnel starting from leaf 1, right? It goes all the way to the spine, to the border leaf in data center 1 via the IP core. Then it goes to the border leaf on the data center 2 to the lean spine, and then going on to the leaf 2, for example, on data center 2. So what we are essentially doing is you're stretching your VXLAN domain. You're not doing any kind of stitching or translation in between. It's as if the remote data center, that is the data center 2, is within the same pod, but separated by an IP core. That's it's a very simple way of doing an stretching or extending your layer 2 and layer 3 domains across your data centers, which involves very less overhead, supported by a lot of platforms, and even Apstra supports this architecture. This kind of an architecture is ideally suitable for small to mid-size data centers. Again, we need to understand the pros and cons, right? The pros, as I said, is a very simple solution, less configuration and stuff like that. But when it comes to scalability, right, when you have more number of leaves, and if you have more number of data centers that you want to interconnect, then you need it basically has a full mesh of VXLAN tunnel endpoints peering, right? Your VTEPs on basically your leaf 1, leaf 2, and data center 1 has a full VTEP connectivity to the remote leaves onto the data center 2. And depending on the number of leaves and racks that you might be having, then it can be in we will be hitting the scale limit. So it's a question of scale versus complexity versus simplicity of configuration and the supported platforms as well. So that's some of the decision points that you might have to think, right? And let's slightly go a little bit deeper. When I say ERB design, what exactly is happening? I'm not going to talk too much into that. Basically, in any data center, you have an underlay and an overlay, right? So in underlay, what happens is you are basically establishing the connectivity between the VXLAN tunnel endpoints, right? So the loopback IPs of the border leaves and the lean spines and the leaves are advertised via eBGP, for example, right? We want to just have one protocol, and it could be eBGP, right? And you can have an IPv4 based underlay or an IPv6 based underlay. IPv6 based underlays offer certain advantages. You don't have to configure IP addresses on links, and you can use BGP unnumbered, which makes your configuration a lot more simpler. And if you're doing your own automation, it can make a lot of sense, because unlike in service provider network, inside a data center, you have a lot of links and BGP sessions, and maintaining and configuring these BGP sessions can be cumbersome. So we have easier ways to deal with that, right? Or especially when you're using tools like Apstra, which can really deploy the entire fabric, design, deploy, and manage, you can go for that. That's one of the perfect solutions for managing and fabric, a complex EVPN fabric. All right, so we talked about the underlay, and the second component is the overlay, right? So the overlay is nothing but all your EVPN signaling that happens between the leaf, spine, and the body leaf. So what is the role of spine in the overlay in the ERB model? Basically, you're not participating in any of the overlay, but you'll be just terminating your eBGP sessions on the spine. The spine will reflect the routes to the border leaf. So it's just you're just having an eBGP overlay session via the spine to the border leaf, right? So that's the only role of the spine. But essentially, as it mentioned here, it's a lean spine, just an IP routing, no VXLAN tunnel endpoints. It participates in the overlay and underlay EVPN signaling, right? Underlay is not EVPN, right? Underlay is just either INET or INET6, and overlay is EVPN address family. And all it does is simple IP routing, and the focus is on bandwidth and ECMP, right? And we need to choose products when it comes to choosing a lean spine, that's what you're looking at. Whereas when you're looking at a server leaf, right, it's more feature-rich box, right? It does the VXLAN tunnel encapsulation and decapsulation. You'll be configuring a lot of ACLs on the leaf, right? And there'll be a lot of customer segmentations depending on how many customers you'll be connecting, and therefore you'll have that much number of VRFs, L2 VRFs and L3 VRFs. There'll be a lot of MAC learning, bump traffic handling, flooding, VXLAN routing. So we need a feature-rich platform, right? It also participates in the EVPN signaling overlay, and that is in VTEP full, as mentioned here, VTEP peering on the server leaves, right? So these are the requirements on the server leaf. And if you look at the border leaf, from a functional point of view, the requirements are almost same as the server leaf, right? Except that you're doing, an inter-DC connectivity. You're establishing EVPN peering between the border leaves so that you can advertise your EVPN, type 2 or type 5 routes to the remote DC. Okay, now that you have configured your EVPN, fabric, underlay, overlay, once you connect your host, and the host sends the first packet, your MAC address will be learned on the MAC VRF. And then immediately your type 2 and type 5 advertisements, if it is an L3 IP prefix, then there are other EVPN types as well, but some fundamental EVPN types or the EVPN type 2 and type 5, they will be advertised to the border leaf, and the border leaf will faithfully advertise it further to the remote border leaves, and so on. So essentially it's kind of flooding your EVPN type 2 and type 5 across your IP core, right? And one thing you need to understand is, you need the reachability of remote leaves also here. That means the loopback IPs of leaf 1 and leaf 2 on the data center 2 has to be reachable from leaf 1 and leaf 2. So you're almost like advertising all the loopback IPs over the IP core so that you have reachability between the VTEP, so that you have the full mesh of VTEP peering, right? So that's the OTT design. So we saw the requirements, right? On the compute layer, you're not doing too much, right? You're just doing some VLAN tagging, and you might be doing an ESI, active multi-homing. So from a host perspective, you're just doing a lag there, right? And we saw the requirements, the functional requirements on the server leaf, the lean spine, and the border leaf in an ERB design. So what kind of products can we choose as in server leaf, given these requirements, right? So there are a lot of options, right? You could go for a shallow buffer, right? And there are Trident 2 and Trident 2 Plus platforms, because Trident is a chipset that is more feature rich, right? It's more focused on features that is needed from a server leaf perspective, right? So we have the 5100 and the 5110 products, but we strongly recommend our customers to move to the Trident 3 based platforms, right? Which are more powerful, better scale. And we have the 5120 and series, right? And different form factors, copper, 100 gig, and so on. So the different server facing interfaces you can use in the server leaf role. Or you can use the Trident 4 platforms as well, like the QFX 5130 or the QFX 5700. So as you can see, these are all Trident-based Broadcom chipsets being used in the server leaf. Of course, you can go for a QFX 10K platform, which has the Juniper Q5 ASIC there, but it comes at a different price point and different port capacities and so on. And then you have, when you're looking at deploying an underlay, which is IPv6 based, right? Then you cannot use all these platforms. Then you're having your choices reduced to the platforms like the QFX 10Ks and the QFX 5120 series, these models, right? So yeah, we need to look at the architecture, what we are trying to do, and then based on what kind of ERB design, and then what kind of buffer solutions we need. For example, if you want really a deep buffer, right, then the QFX 10K will be more suitable, because the Broadcom-based products are shallow buffer products, right? And if you're deploying IPv6 underlay, as I told you, you have these set of choices. And when talking about the lean spine, as I told, there's no VTEBs, it's just participating in EVPN signaling, and it's doing simple IP routing. The focus is on bandwidth and ECMP radix. Then you can go for the Tomahawk-based products, like especially if you are looking at shallow buffers, the 5200 series can be quite interesting. The 5220, if you are thinking at 100 gig and 400 gig DCs, right? So you have these shallow buffer Broadcom-based products. And then when you're looking at deep buffer, we have the ACX 7100 series based on the Jericho, also Broadcom chipset, right? And the ACX 7100 today, you can use it as a lean spine, but in 2022, you're also going to have the ACX 7100 also in the leaf role, where you'll be able to terminate VXLAN, NCAPs and DCAPs, and all these server leaf functionalities are being added there. And then if you're looking at deep buffer, you can use the PTX range of products, and of course you can use the QFX 10K. And of course, when you want a lean spine with an IPv6 underlay, it's again the QFX series. I mean, on a lean spine, because it's doing just plain IP routing, you can also put Trident-based chipsets here, like any of these Trident 3 or Trident 2 or 2 Plus. But why wouldn't you want to do that? Because the focus here is on bandwidth, ECMP, and radix. Whereas the Trident chips are more feature-oriented, you're not going to use any of these features in a lean spine. So it's makes more it's appropriate to use the Tomahawk or Jericho or other ASICs in this space in a lean spine role. And then coming to the border leaf role, right? Again, need some specific features there. So again, Tomahawk is not a good point to position that here. So it's again the Trident-based ASICs here. The Trident 3 and Trident 4 are very good for that. And then you can, of course, use your MX series because it's a Swiss Army knife, right? It's a very flexible platform. You can do a lot of things with MX. You can connect it to IPVPN. You can offer multiple services on MX. And of course, the QFX 10K series. And if you're looking at an IPv6 underlay, then you have special products only for these designs. So these are all validated designs. If you go to the Juniper website, under the data center design, you see these products mentioned, and these are Juniper validated designs, and these are the recommendations for these roles, especially in the ERB design, right? So in the ERB design, as I told you, you see there are two kinds of VXLANs, right? So the intra DC VXLAN that stretches across the leaf nodes. So that's what you see here. That's the east-west traffic. It's based on VXLAN. And then the north-south traffic, any traffic that would egress the data center to the remote data center, is tunneled through this end-to-end inter-DC VXLAN tunnel passing over the IP core, right? And this tunnel is established because we are advertising the EVPN type 2 and type 5 routes to the remote border leaves and to the remote leaves, and they will import these route, EVPN routes based on the configured RD and RT values, and then that's how you establish your standard BGP next hops and so on. So this is an ERB OTT based solution commonly seen, fully supported by Apstra, and for small to mid-sized data centers, as a recommended solution by Juniper, right? Moving on to the next solution that we have that I want to talk today is called the ERB solution, right? But when it comes to the DCI, instead of doing a full mesh over the top, we are going to do some seamless VXLAN to VXLAN stitching, right? So let me explain you the architecture. So like before, we have two data centers, data center 1 and data center 2, right? And in the data centers, you have the leaves, which are the server leaves, intelligent, feature-rich, right? You have your broadcast domains, map, VRF, and your L3 VNIs on the leaves. You have a lean spine, and then the border leaf, we are giving it a new name. It's called as the interconnect gateway, right? It's just a border leaf, but internally in Juniper, we're calling it as an interconnect gateway. So what we are doing in interconnect gateway is we are taking the VXLAN tunnel, any north-south traffic that would come from, let's say, leaf 1 that has to go to data center 2, we will be terminating that VXLAN tunnel on the interconnect gateway, right? We are not extending the VXLAN end-to-end, but we will terminate the intra-DC VXLAN tunnel. It starts from leaf 1 and it terminates on the interconnect gateway. And then we start a new VXLAN tunnel, what we call as an interconnect VXLAN, right? It's also based on VXLAN data plane. And we connect basically this interconnect VXLAN is between the interconnect gateways, right? We are basically stitching one VXLAN tunnel into another VXLAN tunnel. So the intra-DC VXLAN tunnel is stitched to an interconnect VXLAN on the interconnect gateway, right? And similarly, on the remote DC, you terminate the interconnect gateway, and then you stitch it to an intra-DC VXLAN that goes then to your leaf, right? So any north-south traffic, then you're splitting your VXLAN domain into like 3 parts. So you have your intra-DC VXLAN tunnel within data center 1, and then your interconnect VXLAN, and then your intra-DC VXLAN tunnel on the remote data center. So why do we need to do this, right? So as I told you in the previous case, where you're stretching your VXLAN tunnel end to end, you have less flexibility, right? For example, you have a VLAN 10 and let's say VNI 100, then when you plan something in data center 2, you need to be fully aware of what is happening in data center 1, right? You cannot reuse the same VLANs or VNIs because they're all in the same L2 and L3 domain, right? So you don't have any kind of translation or things like that, right? So everything is sort of, even though this data center 2 in the OTT space, even though it's in a remote location, but technically, you can think of all these remote leaves also part of data center 1, right? So your other difficulty is actually maintaining this full mesh of beta peerings, and you will easily hit the scale limits. So in order to avoid that, what we are doing is on the interconnect gateway, we are stitching the VXLAN. We are splitting the VXLAN domain into an WAN VXLAN domain and intra-DC VXLAN domain. So you're basically splitting the VXLAN domain into 2 halves. So how do we achieve this in control plane? So as usual, you have your underlay and then your overlay inside the data center, right? So the overlay is between the leaf one, lean spine, and the interconnect gateway. And you advertise your typical EVPN type 2, type 5, and other EVPN types as well, right? And what you do on interconnect gateway is you re-advertise these EVPN, especially the EVPN type 2, with a new RD and RT and VNI values. It's kind of acting like an intermediate. It changes your next hop and everything. It's kind of an inter-AS system that you might be aware of, right? So you basically do an EVPN peering between the interconnect gateways, right? And the advertisements that are coming from here, the EVPN type 2 and type 5, they will be having a different set of RD and RT values. And then you are basically re-originating these EVPN type 2, only the EVPN type 2, because the seamless stitching today, we are only able to do EVPN type 2, right? For EVPN type, for type 5, we have an IP prefix. You can go for an IPVPN solution. You can terminate the EVPN type 5 on the interconnect gateway and re-originate that prefix as an IPVPN prefix and send it to the remote core, right? That's possible. But when it comes to stretching your layer 2 domain, you are kind of re-advertising your EVPN type 2 signaling with a different set of RD and RT and VNI values. You can translate the VNI values, what you receive, or reuse the same. So you have a flexibility there. You can put some policies there. You can selectively stretch some layer 2 domains instead of having an full mesh of L2 connectivity. What you can do is you can easily extend selective L2 domains, maintaining certain L2 domains within the DC and stretching only what you need, right? You get a lot of flexibility in that, which is more manageable, right? And so that's the part. Today we are doing the interconnect EVPN type 2 advertisements, where you're doing a layer 2 EVPN type 2 stretching across your data center, right? And once this EVPN type 2 reaches the remote interconnect gateway, it will be imported here locally with the RD and RT, the interconnect gateway RD and RT values, and the interconnect gateway will then re-advertise the EVPN type 2 or EVPN type 5 when it has an IPVPN prefixes to the leaves, so that you have that end-to-end connectivity, right? So that's how the signaling and data plane works. So from a server leaf in this architecture, from a server leaf perspective, nothing has changed, right? You're just doing the standard ERB design, your broadcast domain MAC VRF and your L3 VNI. So from a product selection perspective, there is not much of a difference. Basically, it's all Trident based ASICs products, or if you have IPv6 underlay, it's the QFX series, 10K and the series. The lean spine is also, nothing has changed because it's not doing any stitching or anything. It's just doing plain IP as before. But when it comes to interconnect gateway, that's where we have all those new features that I highlighted in the red color. It does the VXLAN to VXLAN stitching. It does VNA translation. You're able to selectively stretch your L2 based on certain policies. Please note that there's no IPv6 underlay supported if you are going to use it in an interconnect gateway. All these are features that is going to come in the future, but today, as of today, it's not supported. And multicast is also limited to ingress replication. That means that there are assisted replications where it can be even more optimized, but we don't have that yet today. And type 5 stitching is not supported, right? As you see here, we are only advertising an EVPN type 2 via this interconnect stitching, right? The type 5, you can do that with, as I told you, you can terminate your EVPN type 5s on the interconnect gateway and re-advertise them as an IPVPN, VPN-v4 prefix via your IP core if you have an MPLS VPN construct on your IP core, right? And when it comes to product selection today, the interconnect gateway, especially if you're doing the VXLAN to VXLAN stitching, the only platforms that supports this is the QFX 10K series and also the Trident 4 QFX 5130 and 5700 platform, right? So that's why when we are selecting products, we need to look at the architecture, what we are trying to do. identify the roles, what it's going to play, identify the features and functions on each of the layers, and then see what products is supported, and and other criteria, right? You have to then look at your port and optics and other stuff. The third option that you might have, right, it's very similar to the one that I showed you, but instead of an VXLAN to VXLAN stitching, what we are doing is a VXLAN to MPLS stitching. From a construct, everything remains the same, right? You're having two data centers. As shown in this picture, you have data center 1 and data center 2, right? And you have a server leaf which has this L3 VNI. So it's very similar to the one that I showed before. The only part is on the interconnect gateway. Instead of stitching a VXLAN to a VXLAN, what you're doing is you're stitching the intra-DC VXLAN tunnel to an MPLS LSP, which is running between the data center interconnect gateways, right? So if you have an MPLS core which you want to leverage, and if you don't want to run an VXLAN in the data plane, so if you want to use MPLS for that, for whatever reasons, right? Like MPLS brings its own protection mechanisms and so on and so forth. If you want to leverage all these things, then you could use this architecture, right? From a control plane perspective, it's similar, right? The leaf does an EVPN type 2, type 5, of course, other EVPN types as well. It advertises it to the interconnect gateway. The interconnect gateway does an EVPN peering to the remote interconnect gateways, and it advertises, reoriginates the advertisement, I should say, with a new RD and RT via the MPLS core. Maybe you might have a route reflector or whatever, right? So that's the way you do the signaling between the interconnect gateways. You have a lot of flexibility there, right? But from a data plane perspective, what you're doing is, the intra-DC VXLAN tunnel is terminated on the interconnect gateway, and the interconnect gateway is a kind of a label edge router, like an edge router, right? PE router from an MPLS perspective. It terminates the VXLAN tunnel and then puts the frame into an MPLS frame, and then sends it out onto your MPLS core. In your MPLS core, it's most probably P. It's going to be label swapped, and then you are going to do some penultimate hop popping, and your remote interconnect gateway might just identify the label. From that label information, it's going to map it to which beta tunnel, and so on here, right? So that's the model of this. So no change in terms of the functionalities expected, right? On the server leaf and lean spine, and the kind of products that you can choose remains the same. But when it comes to the interconnect gateway, what you're doing is an VXLAN to MPLS stitching on interconnect gateway with VNA translation and selective L2 stretch with policies, no IPv6 underlay support, like I said before, and multicast is no assisted multicast, it's only ingress replication, and type 5 stitching is not supported, right? And today only the MX is able to do this, and PTX is on radar. It's coming in 2022, so you can use, today it's MX, but PTX is in the radar, it's being developed. So this can be a quite interesting solution for certain use cases as well. But type 5 stitching is also coming up, so please watch out for the space, and we'll be informing you in our subsequent boot camps regarding all of these developmental aspects of this. Right, so this is the architecture as far as the ERB with a seamless VXLAN to MPLS stitching. And what we're also seeing is a lot of interest in the collapsed fabric architecture, right? So here you see two data centers. Data center 1 is an ERB 3-stage clause where you have a leaf, lean spine, and a border leaf, right? But on the right, you have the data center 2, which is in a collapsed fabric mode. In a collapsed fabric mode, so this is actually the collapsed fabric where you're collapsing the DCI leaf and spine into a kind of a single layer, right? And what you can do is you can connect a leaf layer or a tar layer, whatever you want to call it. You can put it in a virtual chassis. It can be an QFX platform, or it can also be an EX platform as well. And you can connect your host to this virtual chassis. And this virtual chassis can then be connected in an ESI lag, right? Where you can do an active-active multi-homing here. And on the Collapse Fabric, you have those same EVP and VXLAN constructs, right? Your bridge domain or broadcast domain, your MAC VRF, and which is an L2 VNI, IRB, and your L3 VNI, which is the layer 3 constructs, and your VTAD, the basic construct. You have collapsed everything here. And what you can do here is you can do an OTT kind of inter-DC connectivity where you're doing an EVPN peering between the Collapse Fabric and the remote border leaf, and you can exchange your EVPN type 2 and type 5. Basically your overlay can be advertised via the IP core, and you have the VXLAN tunnel stretched between your Collapse Fabric to the remote data center. And when it comes to the platforms that are supported, you see here, you can, as usual, MX, because of its role as a DCI, you have a lot of flexibility there. Of course, you have your Trident-based chipsets here, right? The Trident 3 and Trident 4 feature-rich, because none of the Tomahawk solves the use case for VXLAN, tunnel encapsulations, and so on, right? Of course, 10K, the Juniper Q5-based chipset, this can be quite interesting in this space as well. So these are some of the common architectures that you will see with small, mid kind of data centers. I would just want to show you another topology, an IP class topology. This is some kind of a topology that you will see deployed by hyperscalers, some very large data centers, or very large enterprises as well. And the architecture looks like this. So I have two data center 1 and data center 2. They are interconnected via an IP MPLS core. It's an IP class-based fabric. So in this kind of a fabric, what you see is the compute node. The pink box that you see here is in the compute node. The compute node is a lot more intelligent in this case. So let me zoom it in then. So let's focus on the bottom part, the pink part here. That's a compute layer, the server layer, right? So you have technologies like SmartNIC, which is your network interface card, but it's doing a lot of your data plane processing, right? It's doing MPLS encapsulations, VXLAN decapsulations. It's something like your line card, right? Where your CPU of your server is offloaded, right? You don't do all those expensive operations. You don't use the CPU. The CPUs are for the virtual machines for the end customers, whereas all the packet processing is being done on the SmartNICs. And then what the hyperscalers have done is they have pushed MPLS and routing all the way to the server layer, right? So what they typically do is they have a tendency, they have a lot of virtual machines, and each virtual machine will be connected to their own specific VRFs. And they have MPLS and BGP. They do eBGP to the leaf, right? They advertise the loopback of the hypervisor to the leaf. And the VXLAN tunnel endpoints are then directly on the server. So the leaf and spine play no role in this setup. The leaf and spines are doing only plain IP forwarding, right? And any east-west traffic will be VXLAN encapsulated between the server and the leaf and the spine in this architecture. They just do a plain IP routing. And any north-south traffic, because you're pushing MPLS all the way to the server, so it's actually an L3 VPN, right? So you have your VRFs and you have an MPLS, but your leaf and spine in this case are only IP, right? You don't have an MPLS data plane here. So how do I get my MPLS packets from the server all the way to the border leaf? So there comes in your tunneling solutions where you encapsulate your MPLS or UDP. There are other tunnel options like MPLS over GRE or other IP-based encapsulations as well. But I'm just showing you one example of an MPLS or UDP tunnel, which will be terminated on the border leaf. So any north-south traffic that's leaving the server, going to a remote server, will be tunneled over the MPLS or UDP, and this MPLS or UDP tunnel will be terminated on the border leaf. And on the broadleaf, you'll have a regular MPLS VPN, right? So your VPN V4 routes are advertised, and everything is MPLS based. So that's the kind of architecture you will see on hyperscale kind of an architecture, where most of the things are SDN, right? So they have an SDN orchestrator. How do you set up? Because there's no EVPN here. Many people, many hypervisors, hyperscalers, they don't use EVPN on the server layer, right? They have written their own SDN orchestrators that would program their VTAP endpoints, the discovery of the VTAPs, and the MPLS or UDP tunnel establishment, how to map the verbs to the respective tunnels and so on. So everything is set up by their own SDN orchestrators, or you might end up in solutions like VMware, NSXT, or Contrail, or OpenStack, managing the resources here, right? Like whenever you create a VPC in AWS or something, at the background, you will see all these things are happening, right? So this is the kind of technology which I don't know whether you see a demand for this, but these are typically big cloud accounts, hyperscalers, and pretty large cloud providers who are deploying technologies like that, right? And of course, Juniper has another design, the CRB, or the centrally routed bridging, which we are currently put in the maintenance mode. That means like it's not a recommended design by Juniper. In a centrally routed bridge mode, what happens is, the leaf is connected to a spine. There is no intermediate lean spine. The spine is more intelligent. In this case, we are putting the layer 3 VNI, the L3 gateway on the spine, whereas the leaf nodes are just having the MAC VRF construct or the L2 VNI construct here, right? So any VXLAN routing has to happen on the spine. Your default gateway will be on the spine, right? So that's the difference between a centrally routed bridging and edge routed bridging. Just keep in mind that Juniper has put this in the maintenance mode, and CRB is something that you cannot do in Apstra, which Eric will talk about in the future and in some of the subsequent sessions. So having said that, you'll see the kind of boxes that supports this architecture, the CRB design, right? So any new products that we are bringing in our DC portfolio, like the PTX, the ACX series, the new Trident 4 based platforms, all these will never be supported in the CRB mode. All the CRB related features, all those new products will never get it, right? So that's also one of the reasons to consider whenever you are proposing solutions for your customer. Always think about ERB versus CRB, and when it comes to ERB, always think about have an eye on the DCI solution as well. That's going to be OTT, or whether you want to have some kind of stitching. When it comes to stitching, look what your IP core is supporting, whether you want to do an VXLAN stitching or MPLS stitching, and so on and so forth. That will help you in qualifying the opportunities. Yeah, that's pretty much regarding the architectures. I hope this session helped you a bit to understand the architectures, and hopefully it helps you in better positioning the products and doing the discovery when it comes to new opportunities. I'm just looking into the chat to see if there are any questions. No. So before, maybe I'll take a couple of minutes just to explain the Juniper strategy in terms of silicon that we are supporting, right? So at Juniper, let me make this full screen. So Juniper, we have a rich portfolio of silicon, right? We say the right silicon for the right job. Basically, we have Juniper developed silicon and merchant silicon, basically Broadcom based, right? So as you see here, as you move up the stack, like some of your VMX and VSRX, they are on an x86 platform, right? And then you have the Trio chipsets, which are very flexible, right? The MX and SRX, right? Are extremely programmable, right? they can bring in new features very quickly. But when it comes to, let's say, bandwidth and cost and that kind of discussion, then you need to consider merchant silicon, right? You'll see more focus being pushed into the ACX and product lines, right? Especially the Jericho, Qumran, and for shallow buffer platforms, the Trident and Tomahawk. We always have the merchant silicon. Right, and of course the Express series of the PTX products, which is kind of a nice transition from the QFX 10K to the PTX world. The Q5 evolution of Q5 chipset is actually the BX and the BT and the ZX series of chipsets, right? So we have a pretty good story in terms of the right silicon for the right job. And as you see here, Juniper is continuously investing in the QFX 5K series, right? It's for cost optimized, shallow buffer, low scale systems, whereas when you are thinking about deep buffer and high scale feature rich, then we are talking about MX, PTX, and ACX, right? So the features are coming in for PTX and ACX, where you'll see more EVPN, VXLAN features coming in. Then we will have a very good portfolio complementing the MX and the QFX 10K series. And yeah, that's a broad outline. QFX 5K, shallow buffer, fixed merchant silicon, the ACX for deep buffer merchant silicon, leaf spine DCI, the QFX 10K and PTX, if you're looking at Juniper chipsets for a deep buffer experience, and the MX, very flexible when it comes to DCI. You can collapse the DCI and your WAN gateway. You can do several interesting configurations when you choose the MX as well, right? And here you see the spectrum of products that we offer, right? The Trident 2 and 2 Plus, these we recommend the customers to go to the Trident 3 based platforms, right? The Trident 4 is when you have bigger data centers, more 400 gig oriented. And then you have the Tomahawk based series when you're looking, consider these for lean spine, or when your leaf is not doing anything much than IP routing, try to push in the Tomahawk there. And Jericho today, the ACX is not having EVPN, but that's coming in 2022. Today it's used as an in a lean spine role. And of course, Juniper custom silicon is very flexible, right? So with that, I've completed my part and see if there are some questions that you might have.
No, but it's Eric here. No, I don't see any more open questions. Yeah.
Then it's time for a quick poll. I would also like to understand from the team here. I hope you're able to see the poll. I'm just trying to understand the data center architectures, what you're seeing currently. Are you able to see the poll?
Yes, perfect. I think we can see it, yeah. And I can see that people are answering. So
people answering, yeah. So let's give it a couple of minutes.
Yeah, that's great. And in fact, so if you remember from the agenda, so from now we have finished the first session. So we give you like, a little bit more than 4 minutes now from here until top of the hour. So we begin in 4 minutes with the second session, which is related to telemetry. And once again, please, would appreciate if you could fill out the poll, and you can see also results from your colleagues and see if that corresponds to your view on data center architectures and more. So with that, unless you have anything more to add, Muthu?
Yeah, we'll just take the break, and then when we come back from the break, maybe we'll share the poll results, and then you can take it up from there. Okay.
Yeah, okay, great. So let's take a 5-minute break from here and then come back to the next session. Thank you.
Awesome.
Okay, so I think we're slowly going to start soon. Hopefully now you can see my screen. So we have up until now done the first session, which was very much around different architectures and where each and every Juniper platform fits into different use cases. And for those of you I saw, it was a very good response rate on the poll. So I'm just waiting for my colleagues soon so that we can show you the results, which is usually quite interesting to see how your colleagues in the market, how they look at different challenges or questions in the data center. So while you're waiting for that, after this, then I will do okay. So I think now we are sharing the results. Sarah, could you please confirm that?
Yeah, that's right. I've just shared the results. So do you see that now?
Okay, perfect. Yeah, I can see that, and hopefully everyone else can. So, Muthu, maybe you should comment first on the response we got.
Right. So the first question, like, do you see an uptake of EVP and VXLAN-based fabric in DC deployments? Yeah, it's pretty clear. 90% have said yes. So it's pretty clear that the whole industry is moving towards EVP and VXLAN. They have realized the benefits of that. And the second question was to get an idea of whether the ERB reference design is being a convincing design. And that's like 65 to 35. 65% have said yes, and 35% have said no. That means, you know, there are still customers who still think of the CRB reference design as well, right? So that's also what we see during our opportunities in the sales within Juniper. But 65% to ERB design, they are convinced that that's also in line with what we see. And the third question matches pretty much well with what Eric is going to talk, how complex it is to manage an EVPN and VXLAN fabric without an automation solution. And majority of you have replied either it is very complex or moderate, given the size of your data center, you know, just to configure and manage this network can be without an automation solution. That pretty much explains the need for a solution like Apstra. That's what we also see, what our customers are telling. And the final thing for smaller enterprises, how they see the collapsed fabric EVPN architecture. And, you know, that's an interesting question because, you know, many enterprises, they still have the access aggregation core, the classic design, and, you know, running spanning tree and VRRP and MCLAG and those kind of things. It's pretty interesting to see like 65% have said yes, right? They see the advantage of moving to an EVPN architecture. That's also lines up pretty well with what we see inside Juniper. So thank you very much for the participation of the poll. Awesome, Eric, it's all yours now.
Yeah, thank you. Yeah, thank you for responding. It's always interesting to see a different view, and I think as Muthu just confirmed, I think we have a common view, partners and Juniper, what is happening out in the market. So thank you for sharing that. We will be running a second poll by the end of my session as well, so please stay tuned on that one. Because now we're going into the next topic of today, which is telemetry, and there will be like three main topics, you could say. First, just the introduction, what is telemetry when it comes to Juniper? And then, of course, all the telemetry we have, how can we collect that and make something intelligent? And that's where the Paragon portfolio comes into place. And that's, I will briefly look into the Paragon Insights, which used to be called HealthBot. So if I say HealthBot every now and then, it's the same as Paragon Insights. And then also, I think it's the last acquisitions we made, Paragon Active Assurance, which used to be called NetRounds before the acquisition. And there we also have some use cases within and intra and between data centers where you can do active assurance, which is quite interesting. So with that said, let's look into what is the next thing. So telemetry. And as you, as Muttu hinted, on Thursday this week, we will talk more about Apstra. And Apstra, as you know, is the management or intent-based network solution that's where you do the design, deployment, and also making the operations / assurance of your fabric within your data center. On top of that, you can then optionally add more solutions when it comes to telemetry. And those two we are focusing on today are Paragon Insights and Paragon Active Assurance. And why is that? Well, within Apstra, as you will see on Thursday, we have rich telemetry support. But if we want even more, like for instance, EVPN-based telemetry, or if we really want to understand end-to-end active assurance, then we could add Paragon on top of that. So it's like optional solutions within the data center. And as you probably know, this comes with the Paragon portfolio, and there's other things which usually, I think, for those of you who have been Juniper partner for some time, has associated the Paragon with the WAN, maybe the SP market more. But as you will see, there are some very nice use cases for the Paragon Insights and Paragon Active Assurance within data center as well. Okay. So telemetry. So what is this? Well, first let's do a little recap what has been in the past and where we're going in the future. So as you know, in the past we used to have like most like a network management system, NMSs that could either do SNMP or syslog or CLI. Usually was SNMP, which was fairly good. But as you know, we were not able to detect like real-time, for instance, microbursts. So we have that in the data center and to see where do actually drop packets. That is more or less not doable using any kind of those solutions. So quite recently, for the last 3 years, then we have moved into rather streaming telemetry rather than polling your devices, which was the previous version. So with this, which we will discuss today, then we are actually telling the devices in our network, preferably the data center network, that constantly sending telemetry information to whatever we want and collect it, and then massage the data we get and present some insights in order for you to understand how is my network actually doing. Where we're going is adding another layer, which will be built in for the Paragon Active Assurance. And so then we could do like similar things, like when we do that, adding that in specifically into Evo-based platforms of Juniper, we can then have the Paragon running as a separate service within each and every Evo-based box. And by doing that, we can then add hop-by-hop information, such as latency, congestions, or other KPIs we want to then analyze further once it reaches in this case, collector. And typically that could be Paragon Insight, it could be anything else. So that's where we're going, but that's the future. So that is later on in 2022. And as usual, if you have any questions, please post them in the Q&A. Me and Muttu will try to answer them as good as we can. But looking further then into, different ways of consuming the telemetry coming from a network, typically a data center. So here in this slide, you have like 4 different ways of consuming the telemetry coming out. And first of all, you could call the big guys, Google, Facebook. They just want, they just want the raw telemetry, and they have their own tools and processes to take care of it and do some in-house developed tools that could present some results. Then moving further right, then you have either some open source tools or fairly products you can buy in the market. Either when you already have some tools, they just want to use the Kafka bus or Influx database and then insert all the data into that, or then moving further on to the right, just Juniper plugins. But in an enterprise market, usually the enterprises, they prefer to have like products and solutions from a vendor. And that's where, for instance, the Paragon Insights comes into place, where they get like one platform installed, products and solutions, and with support moving forward. So that's where we focus. But it's good to know if customers would to build something on their own. Of course, it's already there supported. We can just give them some rich telemetry from all the devices we have. And for the recap, is like, as you know, we discussed where we're going in terms of telemetry, and historically, we have been using the pull model, and that means what it says, like from a central point, like typically in history, you had a network management system, NMS, that was on a regular basis polling each and every device for information, and based on that presenting, this is the health of my network, more or less. And as you know, the polling interval cannot be very tight. We're talking about minutes or maybe down to seconds. But as you know, in like 100 gig or 400 gig speed networks, a lot of things happen within like a second or two. So in order to detect that kind of things, we need other ways of sending this information from the devices. And that's where the push model or telemetry comes into place. I wouldn't say next generation because this has been around for some time, but I think you know what it means. So we are constantly then configuring each and every device to send some selected information constantly to a central point where we actually do the processing of the data, maybe using machine learning or maybe even AI in the future, and then present something intelligent on the screen, or have it sent further on to your preferred solution. And of course, using the push model, we are then able to detect almost like real-time scenarios, for instance, which is quite hard to show in a demo, but it's a good video on that, like microbursts. For instance, if in a data center you have like multiple 100 gigs traffic coming in on the interfaces, and if for some reason you want to push that traffic on one single 100 gig, as you know, traditional networking, there will be congestions and you will drop traffic, but that could sometimes be very hard to detect. But using telemetry in this case, that might be an option to find that. Okay, so I think you have, I should not spend too much time on this, but I think you understand the way it works. I mean, you tell a device by configuring it that I want this information constantly fed into my collector, and then devices keep on sending the information. And it could be like different kind of information. So typically we are separating what we call on the control plane and the data plane. Data plane is usually more data nor more real-time things that you can detect, for instance, on an interface level, while the control plane then, of course, more related to your EVPN or BGP or LDP or whatever you want. Also, that could be sent to your telemetry collector and then presented in an intelligent graphical view, most likely. And as you know, there are different ways of sending the data and being encapsulated. And we have, of course, within Junos, we have either proprietary ways of doing it, or we have standardized. And of course, the standardized is probably the most preferred, but there are also some pros and cons. I mean, the pros, I would say, on the native Junos is sometimes we have better support for reasons that we then might go into the more standardized later on. So maybe we start first with the Junos based and then move into more standardized. But basically, we could do almost the same. It's about just what is the encoding and, of course, the transport layer, what it looks like. And if you look into, there's a link in here. If you would like, you can then go to juniper.net and look into the Telemetry Explorer, because that will show you that what kind of informations or sensors it's called. So what is a sensor? Well, that is basically almost like, for those of you who like SNMP, like the MIB, so you decide specifically what kind of information, you can almost say like a data point, this is what I'm interested into, and that specific sensor, that specific data will then be, based on the configuration of that device, will be sent to your central device for your telemetry collector. And as you can see here, these are just an example of some of the packet forwarding engine, routing engine, you know, we discussed this data plane versus the control plane. So it gives you an idea of what kind of things we could send. And of course, usually what you do then, you pick and choose what is the most interesting sensors I want to look into. I have just one example later on what it looks like, typical UNOS configuration, and then you pick that information and then feed it to your collector, in this case Paragon Insight, which we will look into today. And for instance, if you look into the QFX 5000 series, there's a lot of sensor support. What is quite interesting when you look into the data center with EVPN, of course, you would like into what kind of KPIs can we send and look into. And as you will see later on, there are things like, for instance, we could look into how many VTAPs do I have, how many type 2 routes do I have, and so forth. That gives you an indication then, is my network doing as expected, or my intent, if you're talking about abstract language, okay? And of course, what is usually the case is like, unless you have a greenfield network you're deploying, you have some legacy, which means then usually you have maybe old platforms that do not support telemetry in that sense that you can send it like in real time. So therefore, you could have different ways of collecting information. So as you will see in the demo, we're using quite heavily NetConf, where we're actually using NetConf over XML. So that's why we're actually pulling the information, not pushing it. And then we can do a similar thing for the CLI and SNMP. So the good thing is, like with this Paragon Insights, then we can support a legacy, which usually is like the CLI or SNMP as well. But of course, the more modern one, which starts, I would say, with NetConf and onwards, if you go upwards in this slide, where we have more the JTI, the Juniper telemetry interface, where we then can feed almost like in real-time information to the telemetry collector, which in this case is like the Paragon Insights. Okay. And then you might wonder, but how do I configure this one? Well, what you could do is like, this could be like a typical UNOS configuration. So on a device, then first, if you start from the bottom moving upwards, then first the sensor interface. This is the information, the data you want to send. So in this case, you have then the line card interface. We have everything when it comes to usage, and then we do on regular expression. We only want to have them on specific interfaces. And then moving upward, then we decide what kind of export parameters, how would this traffic look like? Then we actually do the export to the telemetry collector. And of course, last but not least, in the end, you have to define where is the telemetry server, where should I send all this telemetry. So that's like the basic. You could set it up, and of course you realize the sensor interface, there you can have lots of information depending on what requirements you have, or your business case you're looking for. I think you've seen this one, but what I would like to do now is first of all look a little bit more into Paragon Insights, and then after that look a little more into Paragon Active Insurance. So what is this? Well, it's a part of Paragon portfolio, but it's like you could say like a semi-open product. What does that mean? Well, as you will see, it comes with playbooks and rules, which will process the data and make some insights coming out of that. We'll discuss a little bit more. But it also makes you as a partner and customers being able to write your own rules and playbooks. That means you can decide what kind of intelligence, what am I looking for specifically for this customer or for this network. And as you can see in here, if you look on going from left to right, it says once again it's HealthBot, but it should be Paragon Insight. So first of all, we can then digest a lot of different kind of inputs, all the way from Kafka, SNMP, and NetConf, and so forth. That's how we could then insert data into the Paragon Insight. Once we're in there, then we use the playbooks and some machine learning as well to learn what is like, for instance, the baseline. What is like after like maybe for 7 days? What is the baseline in terms of how many type 2 routes should I have in my leaf, for instance? What is a normal state and so forth. But if I have then some anomalies, then I would like to announce that something externally, and that could be either on a Kafka bus, or it could be Slack, or it could be an email on REST API. And what is pretty cool as well is like you have something like a closed loop automation. So let's say if you, by ingesting all the data into Paragon Insights, you're running your playbooks and rules, digesting the data that come in, and you find some kind of anomaly that maybe all of a sudden you see much more type 2 routes being received from the other data center, for instance, that could trigger an anomaly. And that, on the other hand, will also trigger some kind of action. And the action engine then could be, in this case, you have like a Python script that, for instance, goes out and maybe close or shut down an interface or reroutes or whatever, based on your defined actions that you have done in the previous. Okay. And just to give you a short introduction, what it looks like in the background for the Paragon Insights. So first of all, you define then what kind of things would I like to look into. I mean, the EVPN stuff, you will see soon what an EVPN playbook looks like. And then, of course, what kind of data do you have in your network, which you're collecting from your data center? And all that data coming in will be then collected in a time series database. And the data will then be crunched by the rule engine, which is defined by the playbooks you defined. And given the results from the rule engine, then we will first of all visualize it. It's like red, green, or whatever. But from here, then we can also do notifications like Slack, email, or webhook. This is something going on, and also integrating a third-party provisioning or NMSs. And last but not least, if you want, you can also trigger like scripting. In this case, could be Python script that goes out and do something in your network. Typically, maybe changing the routing or an interface, physical interface, whatever, depending on what comes out of the rule engine. Okay. So what things can we use the Paragon Insight? Well, it's of course pure networking, so it gives us an even better understanding on top of Apstra. Please remember, we still prefer to have Apstra, but unless you have Apstra, Paragon Insight can also look into how is your underlay doing. We could look into KPIs related to traditional routing such as BGP or BFT and so forth. I think in the data center, where Paragon Insight adds the most value is most likely on the EVPN VXLAN. So we have playbooks, which you then apply on typically on your spinal leaves. And then you start monitoring and analyzing the telemetry from those devices based on EVPN VXLAN KPIs. So one thing I mentioned previously was about this type 2, but it could also be type 5 routes. It could also be other things that are happening in your fabric. As you probably know, we're doing VMware integration with Apstra. We can also do that directly here from Paragon Insight. So we can, from vCenter, get some understanding what's happening in the VMware world, which is usually quite useful in an enterprise environment. And last but not least, quite recently, we also have support for flow, which means we then can detect who's doing the most traffic and who's talking to who, because Paragon Insight supports NetFlow as well as SFlow. But I guess the most important thing to understand, I mean, what kind of things could I detect and report either externally or internally in terms of EVPN VXLAN specifically. And here are those one in green are the ones that comes with the product itself. And so those are default installed. So for instance, you will have the EVPN specifically parameters on leaves and spines, but also microbus, which I discussed. I think I have one slide on that one. And then, as I mentioned, you then have those in orange, white and orange, say, boxes, and those are the community supplied. So as we will see later on, all the rules and playbooks we have within Paragon Insight is also externally publicly announced through GitHub. So if you want to see what kind of specific rules and the playbooks are available, those are found on GitHub, as well as those that has been designed and uploaded by our community. That could be partner, could be customer, and that we'll look into as well. So that's where this semi-open platform comes into place. Okay, that was like a short introduction. I'm thinking now we'll more and more go into the demo, but before we do that, I will just show you a few slides, the workflow within the Paragon Insight. Okay. Oh, sorry. So first of all, it's quite basic. As you will see, you do a discover device, and basically what you do on the simplest manner is like you then enter an IP address, and usually you need some kind of password and username and password for authentication, and then the device will be discovered. And once that is being discovered by Paragon Insights, you have to organize them into groups. That is just the way the product is built. So for instance, you could have like all your spines in one group, leaves and border leaves, and once you have multiple groups. And then once you have done the groups, you can do then applying the playbooks. So I will show someone which is most relevant for EVPN, for instance. And once that is done, you start then collecting information from devices, and you can monitor and see how it works either externally, or you could have export it, for instance, to Grafana, which is quite common to show this kind of data. And just to give you a short introduction what it looks like, as you will see, I mean, the main thing you apply on a device is a playbook. And what is that? Well, the playbook consists of multiple rules, and every rule does something intelligent with the data we collect. That could be, for instance, looking into the data.com, we make some kind of using the sensor, meaning the data, and we do some triggering then, and based on that, Paragon Insight will take some action, either show something or trigger a Python script, which I described. And then the sensor, this is good, just good to know. I mentioned that one. That's actually where you get your data. And then the last three fields, that is more like good to know. But we then look into further what we're collecting from the network. And based on that, then we'll do some triggering, maybe then once again, just alerting, or maybe even triggering a script in the background. So that makes, in the end, could be this closed loop automation if you want. If we look into playbooks and rules, there are some of these which are already there, which are predefined in the product. There are 4 of those currently, and we have, as you can see, a little bit different depending on which kind of role you have. So the EVPN and the spine is actually the same rule. But then on the leaf side, we have some additional rules, which makes sense usually because we do the ERB design, which was previously presented by Muthu. So then we have to look into VTAPs, for instance, the type 2 routes and some other things, which is usually not the case for the spines. And last but not least, we can also do the ping between IRBs. And this is, I understand, quite unique. There's no one else in the market that can do this. And good to know, we talked about this, what kind of, how do we feed information into Paragon Insight? And as you can see here, we actually use an iAgent, and that is actually using netconf. So as you can see, we need to then make sure that we add this configuration into each and every device in order for us to be able to retrieve the information from the device to be pulled and then shown in the Paragon Insight. So, so what kind of things are we looking into? I mean, these are for the spinal leaf. So independently what kind of role you have, we'll do things like, how is my BGP session doing, the BFD and all these kind of things. As you will see, there are roughly 30 plus, 32 or 33 rules, and each rule is doing some kind of checking, is this working or not? So that is running in the background just by enabling one playbook. Okay. And if we further look into the KPIs, specifically on the leaf, we are adding, as you remember, even more things compared to the spine level. And here you can do things which is usually more related to leaf rather than to spine, which then makes sense, okay? And I will then, during the demo then, just enable some playbooks, and they have thresholds. For instance, how many routes am I expected to receive? And default could be 10,000, but of course that could be customized. So depending on your network, then you can then maybe trigger those. And what is also good is, like, within the platform, if you remember, we do have some machine learning into it. And that is typically applied on those which are more dynamic, when, for instance, routes and the interface count and MAC. So what we have there is, like, we have something, rule which is 3 sigma based. That's, you know, standard based, 3 standard based deviation from your mean value. So given that, the platform how it works is actually, once you enable the playbook on a device, depending on exactly on the playbook looks, but typically you have like 1 week, every hour you have a bucket where you collect how many, for instance, route advertised am I seeing, and you do that for like a week, and then you have like a baseline. This is like my typical network, how it works, and from that you start looking into anomalies, which means if you go like 3 sigma from that value you have received during that week, that would raise an anomaly, an alarm, and you will have to take some action that you have configured. One interesting thing, if you go to YouTube, you can look into, which is quite interesting, which is very hard to show in a demo, that is related to microburst. And what is that? Well, I mentioned that previously, that maybe you have problems that the applications owner every now and then complains about, seems to be a problem in the network. That might be right, but it could also be on application level. But what we could detect using the QFXs is also microburst detection. And the way it works is, like, we only enable an EVPN, we enable a playbook. And then once you've done that, then we're able to detect any microbursts. So at least if an application owner comes and says, it seems like we are dropping packets, or there's something wrong with the fabric, this might be one way to show, no, we don't see here. Most likely it's in your application or in a server, whatever. Okay. And before I will do the demo, I just want to show you that this is a typical playbook, and all these could be found then on GitHub. I will soon go there. And in here, as you know, GitHub is something being used heavily by Juniper because we believe in openness. So this is one section, which is, as you can see here in the middle of the slide, related to HealthBot rules. It should be Paragon Insight rules, but never mind. And we also use it for other solutions, as you know, but I will then just briefly go into and show you what it looks like. So in this case, I will show you here. So in here, if you go to GitHub, I hope you can see my browser now. Uttu, could you please confirm that?
Yes.
Okay, great. So in here, there are multiple things when it relates to GitHub and Juniper, but specifically on this Paragon Insight, or HealthBot is used to be called. So here we have then, as you can see, community supplied, which means then, let's see if I can make it a little bit bigger. No. Okay, never mind. Community supply and Juniper official. So first you look into Juniper official, which comes with the product. There's a lot of rules or rather playbooks. And in this case, you look into solution. And as you can see, I think historically, we have been using this solution very much for the WAN, for the SP or the wide area network. As you can see, it also layer 3 VPN, you have QFX, but you have a carrier grade NAT and CFM. So it's a very versatile platform for that point of view. But let's look in a little bit into EVPN VXLAN. So what do we have here? Well, here we have rules, and we also have playbooks. And we can just look into specifically if you pick one playbook here. So so pick up this one. And then you can see playbook contains multiple rules. And one rule could, for instance, be advertise prefix, detect advertised row count threshold breaches, and notify anomalies. So this is like a dynamic rule. And as I said, for each playbook you have, in this case, 30 rules running once you enable this per device. And of course, if you want, you can edit these, remove, add things. It's a very open solution in that sense. But look into the rule then, because the playbook is like where you sum up all the rules, and rules is where actually things are happening, where we are processing the data. So I picked just one rule, which is EVPN received prefix. And this one, as it indicates, just look into the route count thresholds. And when there are anomalies found, there will be some alerts. Okay, so by default, this is 10,000, which could be changed once you enable this rule. But in here, I just want to show you then that it's quite complex. So it's a lot of things happening in here you don't even have to know, but just to show you, for instance, the machine learning. So here you can see, first of all, the algorithm we're using, 3 sigma, meaning that we have 3 standard deviation. We have a learning period of 7 days, 1 week. And we have a bucket, you could say, for every hour for 1 day, which means 24 buckets per day times 7. So we have a lot of buckets where we measure them each and every hour. What is the amount of received routes? And the default is 10,000. And after 1 week, then we know what is like the normal state for our network. And then 3 sigmas out of that is considered an anomaly, and we will take some action. Okay. So I just want to show you, in this case, into the demo, I have here using JCL, which is accessible for you as well if you're being a Juniper champion. And in here we have, as you can see on the left, we have 2 spines, 3 leaves, and 2 border leaves. And we will look into the abstract part of this on Thursday. But today, let's focus on HealthBot or Paragon Insight. So in here then, let's go into the dashboard first. So as you can see here, we have lots of devices we have made available for Paragon Insights. And those devices then have been divided into device groups. For instance, if you look into the DC leaves, we have 5 devices. So these are the devices, the border leaves, and we have 3 leaves. So, and then similar we have for the spines. So typically what you do then is like, I want to, for my, I want to add some playbooks and look into how is my EVPN actually doing. In this case, I'm already running a session here. We can look into that specific EVPN VXLAN KPI. So what I've done here, look into this one. I have started this playbook and containing all these rules. And as you can see here, it's running on 5 devices, all my DC1 leaves, and that's fine. Let's look into what more EVPN stuff do we have. Well, as you can see here, we have, for instance, the EVPN VXLAN. Okay, let's stop that one. So let's say I want to apply this to any devices. That's my leaf, and then I just sorry. I pick my DC1 leaf, and for instance, down here, if I want to specify another count. In this case, if you remember, I have 10,000. If I, rather than the route count should be like 1,000, then I apply that one. Test leave does not matter. Okay, yeah. Sorry, you cannot do anything in here. Okay, now it should work. So that is just to choose what kind of thing you want to look into. In this case, let's see. I'll change here again. I will search again. So now I enable this one, test leave, 5 devices, and then we start getting information from those devices, which are then being presented first here in the dashboard. This is one indication, but also in here we can look into what is the health, more or less. So that here then choose, for instance, and you can do device group, sorry, or in this case I will pick up a device. And as you remember, a playbook contains multiple rules, and the rules is more or less doing a specific check on, for instance, like here indicates red. So this says input errors, links the error interface, VMAP interface. Okay, shut down. Like maybe look into the VPN stuff. So the VTAP remote tap is less than 1, which is typically not good. And I guess it's the same here. Yeah. So here, by running the playbooks and therefore running the rules, we have found out the VTAP count is maybe not correct, and this should take some action. And just to further look into the GitHub stuff, if I go back here then. So, so in this case, I actually kicked off the problem, this one, right? The VPN. Okay, anyway, I picked this one. And then by doing this, once again, we will kick off all these rules, and eventually then we will have all these coming up. So this gives you an indication how your network is doing and so forth. Okay, I will then see, we are 15 minutes to the hour, so I will just quickly finish up with some Paragon Active Assurance. I think.
Eric, is it a good time to start the poll as well before?
Yeah, maybe I should do a little bit more on Paragon Active Assurance before that.
Okay, perfect.
Yeah.
Great.
So Active Assurance, what is that? Well, I think you have figured out it's very much about where you're actively sending traffic from one probe to another, you could say. And the value of that is, of course, this is not something we can do with using Paragon Insights or Apstra. And one use case historically has been very much in Cerberus provider area, where you can see here we have test agents. This is today, most of the time you have actually physical devices or virtual machines, could be containerized, just virtual machines, where you are sending traffic back and forth. And then you define what kind of test you want to do up to layer 7. It could be latency test, it could be checking how is my hypervisor doing, it could be any other kind of things that is related to either a wide area network or, in our case, a data center internally. And the platform itself is quite basic, I would say. So in the middle here, then you have the probes or the tests where you put out in the network. In the Evo-based, as I mentioned, platforms moving forward, you will be able to run the Paragon Active Assurance as a application. So you don't need like a virtual machine or containerized whatever. That could be run directly on your device. And then you will then decide what kind of things do I want to test, which I will show in next slide. And once you do that, then all the results coming in will be fed into a control center. That could be either on-prem or cloud-based. And what maybe mostly the SPs, the service provider or large enterprises, they rather than using the built-in user interface, you can export that into maybe their own preferred tool they already have. So that's very flexible in that kind of sense. But more importantly, what can we do then? I mean, we can do lots of things which is not always related to data center, but things which are interesting. For instance, looking into layer 2, layer 3. For instance, one use case I will show, I mean, for instance, within a rack or within a data center, how is my, what is like the ping time more or less between my probe to my service, or how is my hypervisor doing and so forth. Those kind of things are also supported by using the Paragon Active Assurance. That's within a data center. Also, another use case we have implemented for large data center installation is also to understand, for instance, if you have networks between your data centers that could maybe is not dark fiber, it could be public, maybe multiple networks you're traversing. And that indicates very hard to understand where is the problem. So what we did with Paragon Active Assurance then, so on almost like close to the border leaves, we then installed some test agents, and we start doing full meshed and see where do we see the problems, that is, which network in between the data centers are we having problems. And Mutu, you can launch the poll if you're ready.
Yes.
Yeah. And so that was, it's just, you can see here in the slide, that was like use case 1, where we're doing that in between sites. We can also do, which is quite interesting, within the data center, for instance, between racks or zones. So you have these test agents in a rack, for instance, and you measure, is there any problems between racks? And then you could go even further down into use case 4, where you have test agents running on a virtual machine that you can verify how is my physical NIC, my router gateway, or my hypervisor doing. So that by using that, you can then have a very good understanding where is the problem in my data center, which is quite hard to find otherwise. And I just want to finish up with what to use. We have, for the Paragon Active Assurance, we have different tiers. You have a standard, advanced, premium. And usually what for a data center, you typically use the advanced because then you have all the features within layer 2, for instance, which is quite common. And of course, if you look into, just to give you an indication, we have either the SaaS-based, which is like, as it says, in the cloud. We also have the on-prem, which is what we call the mega version of the Paragon Active Assurance, and then they have the Nano on the left, which is the SaaS-based. And then depending on what kind of use case, what kind of features you're doing, then you have then different kinds of installation, either on-prem or using the cloud. And in the bottom, you can at least get some indication. Once again, it's just list prices, depending on what you want to do. And of course, on-prem, the more use, the more expensive, which kind of makes sense. I think we are close to the hour. I don't see any questions in the Q&A. So I see that people are responding. So I think we maybe we can end the poll. Now I don't see any no. So if you would end the poll, and then we can share the results.
We still have a few more answering at the moment.
Okay, sorry about that. Okay, then meanwhile, you're doing that. So first of all, thanks for attending this one. So as you know, this one was like, and we discussed the architecture in the previous session by Mutu, and then looking a little bit into telemetry. The next session will be very much heavily focused on Apstra. And the third one next week will also to some extent be Apstra, but also including the DC security from Juniper. So if you have time, I saw that a lot of people signed up for this session, but not for this, the part 2 and part 3. So maybe you look into if you have time Thursday and maybe on Tuesday. So are people still responding?
It's slowed down now, Eric. Would you
Yeah.
like to end the poll?
I think we can do that. yeah.
Yes, I'll do that.
Okay.
So, so now you should be able to see the results. So thanks for those of you who actually participated. And first of all, of course, do you have customers using telemetry in the data center? And I think it's yes, 73% no, not that many. And I think that's quite according to what we see, because I think a lot of people, a lot of customers do not really understand the power you can get from telemetry yet. And that's why we have this session. And but I think that eventually everybody will go there, but it will take some time. So Paragon Insights, yeah, will you discuss this? And I think this is also according to usually when we run this kind of session. But there's a lot of interest. How can we increase the visibility of what is happening within the data center, especially around the EVP and VXLAN? So that's where the Paragon Insights is a very good fit. So, okay, good. And question number 3, the Paragon Active Assurance. Okay, that was a little bit surprising that so many people out of you thought this might be a good idea. And I think so, and to be honest, yet we don't have that many that has launched it in data center, but as you see, it could make sense depending on the use case and on customer requirements. So please look into that. I think it could add value to you and your customers. And the last one was about, if you would recommend it. So thank you for just filling it out. It's good for us to get some feedback on the sessions. So with that, I don't see any more questions. I think everything is answered, right, Muthu?
Yes, I don't see any questions, but maybe if you have some special topics that you wish to hear from us, do let us know here in the chat. Maybe we can include that in subsequent boot camps.
Yeah. So with that, first of all, thanks for attending and thanks for filling out the poll. And with that, I will hand over to Sarah.
Okay, thanks so much, Eric and Muthu. And thank you everyone for taking your time to attend today. We hope you'll join us for the forthcoming sessions. Quick question there, Eric. Did you want to just address that question from Asaf there?
Okay, let me see if I can get the question. Hang on. Okay, so the question was, I found some issues with Paragon Insights notification channels like SMTP webhooks. Who can assist? Yeah, I mean, if it's broken, of course, it's JTAG. Otherwise, if functionality, if you have more information, please send it to me. I think I provided an email address previously. And maybe we can assist and look into it and ask internally. So either JTAG if it's broken, or if you think it's something missing, please send an email directly to me and Muthu. Okay.
Okay, great. All right.
Yeah.
Thanks so much, Eric. Okay, thanks everyone. We hope you join us for the next sessions, and this brings our webinar today to a close. Thank you very much. You may now disconnect.